I find that for this set of equations, if I just add the equations, A is going to go away because I have a 2A and a negative 3A, right? So that makes it really easy. So I add the equations. The sum of the two equations is going to be what?
3b equals 6.
Okay.
So
Yeah, negative 3b and 6b is 3b. I don't have to write out anything for A because 0 times A is 0, right? And if I add that to 3b, I still just get 3b, so I don't have to write the 0. Okay, because it's added. If it's multiplied, then, well, I know what to do. And negative 4 and 10 gives me 6. Okay? So conveniently, we didn't have to do much of anything to eliminate A except just add the equations, right? Okay? Then what? Divide both sides of the equation by 3. And we're going to write down every step of everything we do. Now, when you do your homework, especially since all these problems are different, okay, I won't know what the problem was. Now, you don't have to write down all the words in the problem, but you would certainly show me the steps starting by writing down the two equations, right? Everybody's got two equations in A and B on the first problem, right? So if you will write down those equations, then I'll know whether you're doing anything right or not. If you don't write down the equations, just write down, okay, A is 6 and B is negative 2. Well, that's two perfectly nice numbers, but what equations is it supposed to match with? I can't tell, right? Okay? So you got to give me the information, and I want you to write out every step to reinforce what you're doing, because people do algebra by magic rather than by rules, because pretty much they're taught to do it by magic rather than by rules. And we want to get this thing on the basis of some really clear, easily applied rules. One of which is, if you divide both sides of the equation by anything but 0, the equation that you get is equivalent to the equation you started with, right? I don't know if you've ever heard it stated that way. I'd say, you might well have. Okay, maybe not in those exact words, but the exact content. But then you just forget and you just say, okay, I put the 3 under there. What did you just do? I put a 3 under there. No, you divided both sides by 3, right? So we want to put it on that basis. Okay, well, anyhow, 3b divided by 3. I could go into more detail about why that's b, but we understand that it is, and 6 divided by 3 is certainly 2. Okay? Okay, so what do we do now?
Go back and plug B, what 2 where B is in the equation?
Yeah. Replace b by 2. Where?
One of the 2.
Either of these equations, right? Now, it's easier for me to draw an arrow up to the first equation, so I'm going to put it in here, but I could have used the second, right? And out of that, then, comes the equation 2a minus 3 times 2 equals negative 4. Everybody happy and content with this? Okay? I hope so. If not, you get plenty of chance to practice. And if you want more problems to practice, I'll probably put 10 more of these on the website, because I generated 50 of them. There are only 25 of you. Okay? I got plenty of extras. I'll put them up there, so if you want to practice a little more, you can. I might put solutions down for some of them. Okay? That depends on time. Okay, anyhow. We can now solve this equation for A very easily, right? So you get 2a minus 6 equals negative 4. Of course, negative 3 times 2 is negative 6. We know that. Okay, now what do I do? What's the operation?
Add 6 to both.
Add 6 to both sides, right? And you want to say it to yourself that way, because a lot of times, you know I want to add 6 and you do it on this side, you don't do it on that side, because you're not really telling yourself what you're doing. Okay? Yeah, keep your mind engaged. So I'm going to write this out in detail, and I want you to write it out in similar detail when you do it. Okay? I added 6 to both sides, and that gives me then, now I won't make you write the 0 down here because I think you understand that, but if you don't, it's always a good idea. Make sure that you're very clear on every step you take. 2a equals 2, and as predicted, we get whole numbers for a and b, integers for a and b. Okay? So then let's write out the step. Just to reinforce that we're taking these steps so that when it gets complicated, you don't neglect to do those steps. And then we get a equals 1. And then what do we do? Well, we got an A and a B. We're supposed to get an A and a B that work in both equations, right? Well, we're pretty sure that these two work in the first equation if we did our work right, because we used the first equation once we got our B, right? Mm-hmm. Let's check it out in the second equation, right? So So we test. I put a question mark over the equal sign because right now we don't know if they're equal. So we're asking the question, are these two equal? Well, let's see. That's -2 plus 12 equals 10. It's looking pretty good. Anybody see what to do next? Yeah, sure you did. So you got 10 equals 10. Check mark, and we're pretty sure we've got a right solution. It'd be very unusual to have gone through this process this way and gotten a solution, and then that solution happens to fit the second equation, but it wasn't right in the first place because it really didn't fit the first equation. Okay? Now, if your life depends on it, you probably want to go ahead and substitute these numbers in the first equation too, right? Or if it's really important, you know, you're reporting back to somebody and you've got something really important to report to them, you check it out in every possible way, right? So it depends on the importance of this. You're doing this in a test and you got limited time, you probably don't bother going back and checking it in the first equation, but you do check it in the second because I told you to. Okay? Make sense? So it's fairly safe to skip checking it in the equation that you use to get this solution, okay? Not 100%, but it's fairly secure. Okay, so we understand how to do that, right? Okay, now there's another way we could have solved these two equations.
Bless you.
Could you make them equal to 0?
Pardon?
Could you make them both equal to 0 and then solve them as a system?
What you're talking about is the fact that the solution, general solution to the system, is a solution to the homogeneous system plus a particular solution, but we're not going to do that.
Doesn't make sure.
No, no. There's actually something in more advanced mathematics that actually came up in my differential equations class this morning. But, you know, it involves one of their prerequisites, which is a linear algebra course, which is something you don't want to think about at this point. Okay? You did really well here. You know, you might end up thinking about that course. It's a pretty good course, but it's challenging at the level of a good calculus course. Not ready for that yet. And most of you are not in the place where you need to do that. Still good stuff. Okay, well, let's solve the same system. And there's the system.